All right, welcome back. So we're going to talk about scalar and vector projections. So this is basically the same thing, or this is still with the dot product. So they're very similar. Okay, they're in fact you need the scalar projection to do the vector projection. So let's just talk real quick about a vector and taking the dot product. So let's say we have, let's do this in 2 dimensions. Let's say we have v equals AB. So you see letters, so that means it's abstract stuff. Okay. All right, so we're going to take it like so. We already know it goes this way A, this way B. Excuse me. Okay, so one of the things that I want you guys to sort of really keep in mind is that if I think about this, let me do that in a thicker font, different color. Okay, so this here, let me okay. The way I've drawn it, like B is 1. Okay. Okay. So now, what's going on here? So V dotted with I, which is, remembers 1, 0, that's going to be A. V dotted with J is B, right? Okay. These are actually specific examples of vector or of scalar projections. Okay, so these are scalar projections onto the axes. More generally, okay, not more generally, moving forward, A0, which is going to be, I'm going to write this as V dotted with I, and then multiplied by I. So this is now a vector. And 0 comma B, which is V dotted with J in the direction J, those are vector projections. Okay, so in this case, okay, let me draw them. In red here, what I've got, this is A comma 0. Okay. In this case, in red here, that's 0 comma B. Okay, so they're very subtle, they're very subtly different, but they are 2 different things. One is a scalar, one's just a number. When I say scalar, I mean number, and one's a vector. Okay, so now let's take this in general. the scalar projection of A, or let's take B, sorry, onto a vector A is A dotted with B divided by the magnitude of A. And we call this, we write it, the component of B in the direction of A. Okay, so what this is let's draw this out. If I have a vector, let's say I have the vector A here. Okay, and I have a vector B going this here. Okay, this is the component of B onto A. All right, so what it is it's going to be, you take the dot product and then you're going to divide out the length of A. So what I'm going to do, this one's a little bit weird because I drew it badly. I'm basically, yeah, I should have done that, but I'm going to drop the B onto A perpendicularly. So this should be perpendicular. Okay. And so then my scalar projection is just that length. Okay. So that length is the component onto A of B. All right, but the vector itself, okay, the vector itself is going to be the projection onto B. So the projection is going to be this thing, A dotted with B divided by the magnitude of A, and you're going to multiply it by a unit vector in the direction of A. Okay. So that's, again, scalar projection unit vector in direction of A. All right, so it's just a sort of generalization of this idea here. Okay, we can do this on more general sorts of objects. Okay, so let's do an example. Let's do an example. Let's take A equals -1, 3, 7, and B equals 1, 2, 4. Okay, so we're going to find the scalar and vector projections of B onto A. All right, so that's going to be, this is B dotted with A divided by the magnitude of A. That's the scalar projection. Okay, so that's going to be what? 1 times -1 plus 2 times 3 plus 4 times 7 divided by the magnitude of A is going to be square root of 1 squared plus 3 squared plus 7 squared. Magically, this comes out to be -1 plus 6 is 5, 28, 33 over 49, it's 940, 59. Okay, so this is the scalar projection of B onto A, all right? The vector projection of B onto A is going to be that same 33 over root 59 times, now I'm going to take A and divide it by its own length, which we found was the root 59. Okay? This is the vector projection. Okay. Just for fun, let's take the angle between A and B. Okay? So I really want to hit that or make sure we understand that. Okay, the angle between A and B is actually now defined by this inner product. Okay? So it's going to be A dotted with B divided by magnitude of A, magnitude of B. That gives us the cosine of the angle. Okay, so we know A dotted with B is 33. Magnitude of A is square root of 59. Magnitude of B is 16 plus 4 is 20, square root of 21. Okay. So the angle between them is, let's see, let me do that, 33 divided by, I get 20.3 degrees. Let's say 20.36 degrees. Okay. You could also make the argument that it's 159.64 degrees, but we usually just take it to be the one between 0 and 180. We don't worry about where it's pointing or not, okay? All right, I'll see you all in the next video.